So, most important component of these topics is covalent compounds. And these involve nonmetals. And we know the nonmetals are on the right-hand side of the periodic table. Covalent compounds are made up of covalent molecules, often, and we know that these involve the sharing of electrons, and the bond is represented by a line. So if we take hydrogen, for example, we know that there are 2 electrons there, which is 2 electrons, a single bond. So we have one of the diatomics, hydrogen. Similarly, we can have oxygen, which is a double bond. We know the diatomic is O2, but here we have 4 electrons, which is a double bond. And then finally, we take nitrogen, which is N2. We can see that we have 6 electrons, which is a triple bond. And as we go down this series, we know the bonds get shorter and stronger. So that's important to remember. But those are all examples of covalent bonds sharing of electrons. In addition, I want to remind you that fluorine, chlorine, bromine, iodine are diatomic as well. These are diatomic molecules. They can be solids, such as iodine. They can be liquids, such as water. And they can be gases, such as CO2. And you can see that in water we have single bonds between the oxygen and the hydrogen. In carbon dioxide we have double bonds between the oxygen and the carbon. And in the solid we have a single bond between the iodines. And when we talk about solids, they generally have melting points less than 300 degrees C. So, generally we have polar and non-polar pure covalent bonds. So let's look at polar covalent bonds to begin with. We look at HCl. Obviously, we've got 2 electrons there, and then if we want to make sure we have, okay, chlorine has 8 valence electrons. It's very happy and stable. Hydrogen has 2 valence electrons. It's also happy and stable because it's like helium. So they're happy, that's a stable molecule. We have the electrons, but we want to recognize that this is unequal sharing of electrons. This unequal sharing is due to electronegativity. Okay, and we know chlorine is more electronegative than hydrogen. And so what we see is this HCl bond, and the electrons go towards the chlorine. This has a partial negative charge, this has a partial positive charge. That's a small delta, partial negative, partial positive. And this electronegativity is the ability of an atom in a covalent bond to pull electrons towards itself. and we know fluorine is the most electronegative element, and as we move away from fluorine, electronegativity decreases from right to left and from top to bottom. Electronegativity decreases. So all we have to do is look for our elements on the periodic table and recognize which is more electronegative and which way the bonds are going. So if we take an example such as water, okay, we can see that the oxygen bonded to the hydrogens. We know oxygen, if we look at our periodic table, is more electronegative than the hydrogens, so the electrons are moving this way, and so overall we can see that we have polar covalent bonds. But more significant to that is then we have this overall polarity to see that this is a polar covalent molecule. So there are two things to consider. Does it have polar or non-polar bonds? And then is it polar or non-polar? We look at carbon dioxide, we see that the oxygen again is more electronegative than the carbon. The electrons are going this way, so again we have our polar covalent bonds. But these polar covalent bonds mean that the overall molecule is non-polar.